Hello everyone, I am Bhupesh Kumar Devangal, lecturer Government Polytechnic Surajpur. Welcomes you all to the course Essential of Surveying, Application and Technique. Today we begin with our lecture of this course. We will cover the following key points. Introduction of ADM, basic principle of ADM, types of ADM, application of ADM, introduction and application of total station. So what is ADM? The full form of ADM is the electronic distance measurement. Electronic distance measuring instrument is a surveying instrument used for measuring distance electronically between 2 points through electromagnetic wave. Electronic distance measurement ADM, that is ADM, is a method of determining the length between 2 points using phase change that occur as the electromagnetic energy waves travel from one end of the line to the other end. So we are various type of distance measurements, types of distance measurement. Let us discuss various type of measuring distance between 2 points. There are three methods of measuring distance between two points. First, DDM, that is a direct distance measurement. Second one is ODM, optical distance measurement. Third, ADM, electronic distance measurement. Let us discuss each of them and understand the individual method of measuring distance between 2 points. First, we will discuss direct distance measurement. In this the distance is measured between 2 points by the mean of chaining or taping, and second one is optical distance measurement. In this this measurement is conducted by tachometry, horizontal substance method or telemetric method. These are carried out with the help of optical wedge attachments. And third one is EDM or electromagnetic distance measurement. Electronic distance measuring is a method of determining the length between 2 points using phase change that occur electromagnetic energy wave travel from one end of the line to the other end. The method of direct distance measurement cannot be implemented in difficult terrain. When large amount of inconsistency in the terrain or large obstruction exists, this method is avoided, such as when there is a pond in between 2 points or a hill in between the 2 points. In this we cannot do the direct distance measurement. In this, as an alternative to this, optical distance measurement method was developed. Still, it gained a disadvantage of limited range of measurement. It limited to 15 to 150 meter with an accuracy of 1 in 1000 to 1 in 10,000. Above all, we have EDM with an accuracy of 1 in 1 lakhs, having a distance range of 100 km. With the help of EDM, we will measure the distance between 2 points up to the range of 100 km. Electronic distance measurement in general is a term used as a method for distance measurement by electronic means. In this method, instruments are used to measure distance that rely on propagation, reflection and reception of the electromagnetic wave like radio wave, visible light or infrared waves. Sunlight or artificially generated electromagnetic wave consists of waves of different wavelengths. The spectrum of an electromagnetic wave is shown below. In this, among these waves, microwaves, infrared waves and visible light waves are used for distance measurement. There are various types of electronic distance measurement instrument. EDM instruments are classified on the based of type of carrier waves. The first type is a microwave instrument, and second one is infrared wave instrument, and third one is light wave instrument. Let us discuss each of them in detail. First, microwave instrument. This instrument make use of microwave and named as telerimeter. This instrument use microwaves to measure the distance between the 2 points. They are light and highly portable. Telerimeter can be used in day as well as in night. The range of this instrument is up to the 100 km. The second type of EDM is a infrared wave instrument. In this instrument, amplified modulated infrared waves are used. Prism reflector are used at the end of line to be measured. These instruments are light and economical and can be mounted on theory light. With this instrument, accuracy achieved is plus minus 10 mm. The range of the instrument is up to the 3 km. The instrument available in a trade name as Distomat. And third one is a visible, third type of idiom is visible light wave instrument. This instrument rely on propagation of modulated light wave. This type of instrument was first developed in Sweden and was named as geodemeter. During night, its range is up to 2.5 kilometer, while in the day its range is up to 3 kilometer. Accuracy of this instrument varies from 0.5 mm to 5 mm per kilometer distance. Now we will discuss the principle of electronic distance measurement. The basic principle of electronic distance measurement, that is EDM, is that electromagnetic waves are generated, modulated and then propagated. They are reflected at the point up to which distance is to be measured from the instrument station and again received by the station. The time taken by the wave travel is the 2 times the distance may be measured, and knowing the velocity of wave, the distance may be calculated. However, time is too short. Measuring the time taken is difficult. The improved technique use phase difference method, in which the number of complete wave and incomplete wave is measured. Knowing the length of wave, distance between 2 points are calculated. To understand the basic principle of electromagnetic distance measurement, first of all, we understand the properties of electromagnetic wave. The behavior of electromagnetic wave is extremely complex in nature and can be represented in the form of periodic sinusoidal waves, as shown in the figure below. The wave complete a cycle in moving from an identical point A to E or B to F or D to H. This is when waves is travel from A to E or B to F or D to H, that is identical point. It is known as one cycle. The number of time the wave complete a cycle in 1 second is termed as frequency of the wave, and it is represented by the F, and the unit of frequency is hertz. The length traveled in 1 cycle by the wave in termed as wavelength and denoted by lambda. The period is the time taken by the wave to travel through 1 cycle or 1 wavelength. It represented by t in second. The velocity of the wave is distance traveled by the wave in 1 second and calculated by the formula V is equal to F into lambda, that is frequency into wavelength. Frequency is inverse of the time period, that is F is equal to 1 by t, where t is equal to time in second and V is velocity in meter per second. Another property of the wave known as a phase of the wave denoted by symbol phi. As we discussed, property of electromagnetic waves can be represented in the form of periodic sinusoidal wave, and corresponding phase angle is represented as following. The wave is travel from A to B, B to C, C to D, D to E, E to F, F to G and G to H. As the wave is starting from A, the phase angle is 0. When it travels and reach B, the phase angle changes to 90 degree. When it reaches to C, the phase angle changes to 180 degree. When the wave reaches the point D, the phase angle changes to 270 degree. And when it reaches E, the phase angle reaches to 360 degree. And this cycle is repeated in other cycles as well. Measurement of transit time in EDM. Say AB is the survey line to be measured having a length of D. The EDM equipment is placed at end A and end B. A transmitter is placed at A and receiver is placed at B. The transmitter lets propagation of electromagnetic wave toward B. A timer is also placed. At the instance of transmission of the wave from A, the timer at B starts and stops at the instant of reception of incoming wave at B. This enables us know the transit time for the wave from point A to B. This figure shows the 2 points which the distance between which the distance is to be measured, that is A and B, and the distance between A and B which is we are going to calculate it, that is distance D, is shown in the figure below. From the transit time and known velocity, the distance can be easily measured. Now to solve the problem arises due to difficulty in starting the timer at B, a reflector can be placed as shown below instead of receiver at B. The figure shows that at point A, EDM is set, and at point B, reflector is set. From EDM point A station, wave is propagated, and incident on reflector and reflected back and reflected to EDM. Measurement of distance with EDM and reflector. As explained, let the wave get transmitted from A and reflected from B. If the received signal is out of phase by a measure of del phi, then equivalent distance is small d is equal to del phi delta upon 360 degree. Thus, the distance is calculated as from the equation shown below. D is equal to half of n into lambda plus del phi upon 360 degree multiplied by the wavelength lambda, where n is the integral number of wavelength. And this figure shows the how the wave travel and reflected back. There are several error in electronic distance measurement. Error in the electronic distance instrument can be classified into three main categories: personal error, instrumental error, and natural error. The personal let us discuss the each type of error in detail. Personal error. This error arises due to human factor during the operation of EDM instrument. The following are the type of personal error. First, inaccuracy in initial setup. If the EDM and reflector are not properly aligned at the beginning of the measurement process, it can lead to significant error. This could be due to carelessness or inexperience in setting up the instrument at the desired station. The second type of personal error is instrument and reflector measurement error. This error occurs when the user does not correctly measure the distance between the instrument and the reflector. A small mistake in reading or interpreting a measurement can lead to cumulative error, particularly in large survey. Third type of personal error is error in determining atmospheric condition. Incorrect determination of atmospheric conditions such as temperature and pressure can lead to inaccuracies. EDM device often require input about this condition to correct the atmospheric effect on signal propagation. The second type of error is instrumental error. These errors are related to the equipment used in the measurement process. Let us discuss various type of instrumental error. Calibration error. Calibration is the process of configuration the EDM to ensure it provides accurate measurement. If the instrument is not properly calibrated, it can yield incorrect distance measurement over the time, and calibration might drift, leading to the error. And second type of instrumental error is maladjustment. EDM instrument, like any precision instrument, can become maladjustment due to the physical wear and tear, handling, and environmental factor. This maladjustment may cause error in the instrument process, especially if the instrument is not checked regularly. Third type of instrumental error is reflector error. Reflector used in conjugation with the instrument can introduce error if they are not correctly positioned, are damaged, or if their reflective properties degrade over the time. The third type of error is natural error. Those errors are caused by environmental conditions and natural phenomena is called the natural error. Let us discuss the various natural error occurred during EDM distance measuring process. Atmospheric variation. Change in temperature, pressure, and humidity can affect the speed of electromagnetic wave used by EDM instrument. Microwave EDM instruments are particularly susceptible to this variation. The speed of signal propagation can alter by this condition, leading to incorrect distance measurement if not properly corrected. The second type of natural error is signal refraction. Refraction occurs when the signal bends as it passes through layer of air with different densities. This bending can cause the signal to take a slightly longer or shorter path than expected, resulting in measurement error. Multiple refraction where the signal bends several times can compound this error. Understand and mitigation this error is crucial for achieving accurate measurement in surveying and other applications where EDM instruments are used. Regular calibration, careful setup, and consideration of environmental conditions can help minimize the impact of these errors. Let us discuss the application of electronic distance measurement, that is EDM instrument. The application of EDM instrument is serving essential for accurate measurement distance between 2 points, especially over long distance or difficult terrain. These are some key applications of EDM in surveying. The first application is topographic survey. EDM instruments are used to measure distance in topographic survey, where accurate data on the land surface feature is needed. This data help create detailed map and model of the terrain. construction survey. In construction project, EDM instrument help measure distance for setting out point, alignment of the structure and ensuring the construction align with the design specification. The third application is boundary survey. EDM instrument provide precise measurement for establishing property boundaries, ensuring that the legal description of the land are accurate. The next application is the mining. In mining survey, in mining, EDM instrument help measure distance underground, which is crucial for mapping tunnel shaft and ensuring safety. The next application of EDM is deformation monitoring. EDM instruments are used to monitor the deformation of structure like dam, bridge and building by measuring small changes in distance over a time. The next application of EDM is hydrographic survey. In hydrographic survey, EDM instrument help measure distance across the water body, aiding in the creation of nautical charts and the management of water waves. The next use of EDM is route survey. For transportation projects like roadways and railways, EDM instruments are used to measure the map, the route alignment. The next application of EDM is remote area survey. In remote area or difficult to access area, EDM instruments are enable surveyor to measure distance without needing a clear line of sight, as some advanced model can penetrate obstacles like vegetation. And various other applications are also for EDM. Overall, EDM instrument enhance the accuracy, efficiency and reliability of the distance measurement in various surveying applications, making them important tool in modern surveying practice. There are various advantages of electronic distance measuring instrument, which are following. The first advantage is high accuracy. The EDM provides high precise distance measurement between the 2 points, often within the few millimeter. The second advantage of EDM is the fast data collection, result in saving in the field work. The third advantage of EDM is long distance measurement. EDM is capable of measuring long distance between 2 points, sometimes several kilometers with high accuracy can be measured. Versatility, work in various environments including rugged or obstructed terrain. The next the advantage of EDM is ease of use. EDM is having user-friendly interface and straightforward operation process. The next advantage of EDM is reduction human error. As in the case of chaining or taping, there are many type of human error. In case of EDM, the various type of error can be that the error associated with manual distance measurement technique can be minimized. The next advantage of EDM is data storage. In many EDM instrument can store the data electronically, which can be used later for later analysis process. With many advantage of EDM, the EDM is having following disadvantages as well. First of all, this is cost. Typically, the EDM is more expensive than traditional surveying equipment. And the second disadvantage is power dependency. As the EDM is a electronic instrument, it requires a reliable power source. Battery failure can result in failure of the operation. And the next disadvantage of the environmental limitation, performance can be affected by extreme weather conditions such as heavy rain, fog or snow. In such weather condition, we cannot measure the distance between 2 points. The next disadvantage of EDM is line of sight requirement. The EDM require a clear line of sight between the instrument and targeted. Though this disadvantage can be some advanced instrument can mitigate this to an extent, but this is very limited. Calibration and maintenance. Regular EDM requires regular calibration and maintenance to ensure accuracy. This is adding to operation cost. And the last disadvantage of EDM is skill requirement. EDM requires training and expertise to operate effectively and interpret data correctly. Let us come to our next topic, that is total station. Total station is an advanced surveying equipment which is combination of electromagnetic distance measuring instrument and electronic theodolite. It is also integrated with microprocessor, electronic data collector and storage system. The instrument can be used to measure horizontal and vertical angle as well as sloping distance of object to the instrument. While electronic distance measurement instruments are primarily designed for measuring distance, angle measurement is typically performed using instruments like total station, which combine ADM capabilities with angular measurement tool. This figure shows the total station. There are various type of capability of total station. A microprocessor unit in total station process the data collect to compute. First, the average of multiple angle measured, average of the multiple distance measured, horizontal distance, distance between any 2 point, elevation of the object, and all the 3 coordinate of the observed point. Data collected and processed in a total station can be downloaded to computer for further processing. Total station is a compact instrument and weight 50 to 55 Newton. A person can easily carry it to the field. Total station with difference accuracy in angle measurement and difference range of measurement are available in the market. The important operation of total station. The first operation we will perform with the total station is the distance measurement. Electronic distance measuring instrument is a major part of total station. It ranges from 2.8 km to 4.2 km. The accuracy of measurement varies from 5 mm to 10 mm per kilometer measurement. They are used with automatic target recognizer. The distance measure is always sloping distance from instrument to the object. The second operation that we will proceed with the help of total station is angle measurement. The electronic theodolite of total station is used for measuring vertical as well as horizontal angle. For measurement of horizontal angle, any convenient direction may be taken as the reference direction. For vertical angle measurement, vertical upward, that is zenith direction, is taken as reference direction. The accuracy of angle measurement varies from 2 to 6 seconds. There are various parts of total station. First, electronic display. 1 and 2 part we will discuss EDM and electronic theodolite, and the third is electronic display. Electronic display unit is capable of displaying various values when respective key are pressed. The system is capable of displaying horizontal distance, vertical distance, horizontal and vertical angle, difference in elevation of 2 observed points, and all the 3 coordinate of the observed point. And the next part of the total station is electronic book. Each point data can be stored in electronic notebook, right, compact disk. The capacity of electronic notebook varies from 2000 point to 4000 point data. Surveyor can unload the data stored in the notebook to computer and reuse the notebook. Application of total station. There are various application of total station. Total station are highly versatile instrument used in a variety of surveying and construction application. Due to their ability to measure distance, angle and elevation with high precision, here are some of the key application of total station. The first application of total station is topographic survey. In topographic survey, mapping terrain, total station are used to measure and map the contours and feature of the land. This data is essential for creating topographic map, which are used in planning and design process. The second topographic survey application is elevation measurement. They help determine the elevation of various points on the land, aiding in the creation of detailed terrain model. The second application of total station is construction layout. In the construction layout, the first application is setting out. Total station are used to mark the position of the structure, road and other construction element on the ground according to the design plan. This ensures that construction align accurately with the intended layout. And the second construction layout application is alignment and leveling. They are used, total station are used to ensure that structural elements like beam, walls and column are aligned and level, which is critical for the stability and integrity of the construction. The third application of the total station is boundary and the land survey. That is first application of boundary and land surveys, property boundary definition. Total definition are used in cadastral survey to define and record the precise boundary of the properties. This information is crucial for legal and real estate purpose. And the second application of boundary and land survey is subdivision. The total station help in dividing land into plots for development or sale, ensuring that each plot is accurately measured and recorded. The fourth application of total station is infrastructure development. In the infrastructure development, the first application in road and highways. Total station are used in the design and construction of road and highway, helping to ensure that curve, grade and alignment are accurate. And the second application in infrastructure development is bridge and tunnels. The total station are used in the construction of bridge and a tunnel to ensure that all the components are positioned and aligned correctly. Application of total station in monitoring and deformation survey. In this, the first is structural monitoring. Total station are used to monitor the deformation and movement of structure such as dam, bridges and building over time. This helps detect any shift or settling that might indicate structural issue. The second application under this monitoring and deformation survey is slope stability. The total station are used in geotechnical monitoring to measure the movement of slopes, helping to predict and prevent the landslides and failure of the slopes. The sixth application of total station survey is mining and excavation. In the mining survey, the total station are used to survey the layout of mine both on the surface and underground. They help in mapping tunnels, shaft and other underground features. And the other use under this is they are used to measure volume of excavated material, stockpiles and pits, which is essential for project planning and resource management. The next application of total station is utility survey. Under this, the first application is mapping utilities. Total station are used to map the location of underground utilities like water pipes, gas line and electric cable. This information is critical for construction planning and maintenance. Other application under utility planning is utility line alignment. They help in laying out and maintaining the alignment of utility line, ensuring that they following the intended path. The other application of total station is in the archaeological survey. In the archaeological survey, site mapping. Total station are used to map archaeological sites, recording the precise location of artifacts and features. This help in documenting and analyzing historical sites. And other archaeological application is excavation planning. They assist in planning and documenting the excavation process, ensuring that all the findings are accurately located. The other application of total station is robotic and remote survey. Under this application, the first application is remote operation. Robotic total station can be operated remotely, allowing us single surveyor to control the instrument from a distance. This is especially useful in hazardous or hard to reach area. And the second application under the robotic and remote surveys, automated data collection. They can be programmed to automatically collect data at the regular interval or in predefined pattern, improving efficiency and reducing the need for manual intervention. The last but not least, the application of total station is precision agriculture. Total station is also used in agriculture for field mapping. Total station are used to map agriculture field accurately, helping in planning irrigation system, drainage and planting layout. The other application in the agriculture field is yielding monitoring. They assist in the precise placement of sensor and equipment used for monitoring crop yield and soil condition. So here we will conclude our lecture. We study today ADM and total station, which are modern surveying equipment which are used nowadays, frequently used in the field in the construction industry.